Okay, so again, lesson 4 is on percent increase and decrease. So now this is telling us we're working on a percent decrease. So Ken said he's going to reduce the number. So reduce, that's decreasing the number of calories he eats during the day. Ken's trainer asked him to start off small and reduce the calories by no more than 7%. So he estimated he consumed 2,200 calories per day instead of his normal 2,500 calories per day. Did he reduce his caloric, his calorie intake, by no more than 7%? Okay, well, if we use our formula here, amount of change divided by original, how much did he change the number of calories he takes? Well, we can find that out by subtracting. This is going to be, remember, the amount of change. It's not saying, hey, he's changing it by 5 cards or whatever. We're saying they're giving us both numbers, right? So you just subtract them to figure out how much it changed. And then what is the original amount? His normal, 2,500. All right, so this ends up being 300 divided by 2,500. If you grab a calculator and divide that, you get 0.12. And if you change it to a percent, you move it over 2 places, and you get a 12% decrease. So if we make sure we're answering the question being asked, it said, did he reduce his calorie intake by no more than 7%? No. No, he decreased it by 12%. Okay. All right, another example here. Skylar is answering the following math problem. The value of an investment decreased by 10%. The original amount was $75. What is the current value? So Skylar said 10% of the 75 is $750, and since it decreased, you have to subtract it. Now it wants us basically to create an equation and kind of show how we get to this answer, kind of giving us an answer, okay? Don't worry about explaining your thoughts to the rest of the class, okay? But I want to show you 2 ways we can think about this, and it's going to go back to our equation, this equation. Quantity equals percent times whole, okay? And we're actually going to do it twice because I want to show you 2 different ways we can think about it using the same formula, okay? Okay, and again, this one we're not really finding, we know the percent, that's why I'm going back to our original equation here. All right, we want to know what's the current value, okay? We know the percent, 10%, so I am going to change that to a decimal right away because we can't do anything until we change it to a decimal. And what was our original amount, our whole, okay? Well, it's 75. So I'm basically just going to go 10%, 0.10 times 75, and I get $7.50. That's what Skylar set up here. Now, you have to subtract it. This is what I mean. It doesn't mean the new investment, which is decreasing by 10%, is $7.50. It means we take the original minus how much it decreased, and we get $67.50. Now, here's how I want you to think of it a little bit differently. If it decreased 10%, what percent is left? Meaning, how much of the investment is left? Well, if you go 100%, because remember the whole is 100, minus 10%, that equals 90%. So we can think of it maybe as what percent is left? 90%. So as a decimal at 0.90 times our whole, that doesn't change, it's still 75. And if you type that into a calculator, guess what? You get to $67.50 right away. Okay? So we got to start thinking of what percents mean, right? If it's decreasing by 10%, that means there's 90% left. You get the same answer either way. So you can kind of go with what makes sense to you. Okay? I think one more example. Justin earned 8 badges in Scouts as the Scoutmaster's last report. He wants to complete 2 more. So he's already earned 10, and he wants to complete 2 more. So he'll have a total of 10. So if he completes the additional 2 badges, what will be the percent increase? All right, so again, I want to show you 2 different ways to do it. If we do amount of change over our original. Now, our original, that's whole, right? And then I want to show us, what if we use this? Our equation we've been using, okay? So if we take the amount of change, well, it's changing 2. He wants 2 more. What's our original? Okay, our original is what he has. It's the whole, it's 8. And if you go 2 divided by 8, you get 0.25. You make that into a percent, and it's 25%. Okay? Now over here, we can think of it as, what's our whole? Well, our whole is 8. We just said that. We don't know our percent, but our quantity is 2. 2 out of the 8 he's increasing, right? Well, guess what? You divide both sides by 8, you're still going to get 0.25, which is 25%. All right, now express the 10 badges as a percent of the 8 badges. Okay, so using quantity equals percent times whole, 8 is still the whole. That's what he has. We don't know the percent, but now we want to express the, you know what, let me show you another hint here. Of the badges, remember? Of, the word of goes with whole. There, that might make more sense why that's 8. But then 10 is the quantity. 10 is what percent of 8? Well, divide both sides by 8. We get percent equals 1.25. Well, guess what? You move it over 2 places, that's 125%. Okay, so 10 badges would be 125% of the 8 badges. Okay. All right, so again, keep in mind what we're trying to do here. We want to find the percent by which something is increasing or decreasing, okay? Focus on what your original is, what your whole is, and then make sure either equation that you use, that you're using the tricks I've taught you, either the amount of change or like of means whole or anything like that. And then when you finish, make sure your answer makes sense.